Here we will solve an application involving an exponential growth model. I've got the question, and of course, as always, pause if you need to read through the details. And I also here included some information from our text. And this particular formula gives us a model for uninhibited growth. It says of an insect population, but it really could be any type of uninhibited growth. And here we see that the number of insects is represented by P after T days have passed. P naught or P sub 0 here is the same thing as P of 0, which is the initial number of insects. And K here, is a positive constant that represents the growth rate. Okay, so K, again, located here, and P, the initial number, or P sub 0 rather, initial number located here. So we can just use this information alone to answer parts A and B, where it says A, determine the number of insects at T equals 0 days. That's the same thing as the initial number of insects, which is this coefficient, 300. And then when it asks what's the growth rate, it's the coefficient here in the exponent, which we would have to represent as a percent. So 0.07 as a percent is 7%. So those can be answered just by identifying parameters within the form of the equation itself. The rest of these questions, we have to do a little bit of calculations, and we could use a calculator to help us with that. So when it asks what is the population after 10 days, which is a T value, that's the same thing as finding P of 10, which when we substitute, that's going to be 300. E raised to the 0.07 times 10. So just make sure that 10 is in the exponent. You round that number to the nearest whole number, you should have 604. When, these two questions both ask when will. So in this case, we're looking for a T value. We know the population size, but we don't know what T equals. So in this case, I would say something like 420 equals 300 e to the 0.07 T, and I'd solve that equation. I could do something similar for part E. I could say 600 equals 300 e to the 0.07 T. And you might ask, well, why did I pick 600? Where'd that come from? And that's double the initial population. Double 300 is 600. So this one should be 4.8, and this one should be 9.9. Now, if you want to keep watching to see how that works out, how those T values come to be, just continue this video here. So I'm going to do one of these, like the steps of solving one of these. I'll pick that first one. Just rewrite the equation first of all. And if I want to find what T equals, I first need to isolate the exponential piece. That means move this 300. So to move that, I have to divide by 300. That's its inverse. And I come up with 1.4. Then the next step is to rewrite this in its logarithmic form. So in general, the logarithmic form is going to be log and then the base of some number equals the exponent. So in this case, that works out as log base E of 1.4 equals the exponent, which the exponent from that expression is 0.07 T. Well, log base E can further be simplified or rewritten as the natural log of 1.4. And so then I could go ahead and get an approximate value here for natural log of 1.4, or I could just keep it like it is and divide both sides by 0.07 in order to get, what did I say that value was earlier? Should be approximately 4.8. 4.8 should be T. Now, If you do have a calculator that uses parentheses, make sure you close the parentheses here, then divide by 0.07 to get that value.